In general, what are the workloads that these guys use in Formula One, for instance? What is a common workload?
For Formula One, very often like the individual car, the airfoils of the car, how does it perform? Some people though, like there's rain on the track, like how do the tires perform in the rains. Other types of simulation, like we do have customers in NASCAR, and like for example, NASCAR is like very often with NASCAR, the cars kind of bunch up, and that changes the aerodynamics and everything of the cars, and so they also look to simulate that as well.
Like crazy amounts of data, of course. That requires a lot of compute power.
To your point, though, it is a big compute job. That's why our instances on Azure, we just actually released HPV 5, which is an AMD chip that work with them on developing specifically for these types of workloads. It's got an RDB InfiniBand interconnect.
So Azure had these super powerful compute resources there in the data center, and of course, Philly can provide that easy access for especially applications that require visual interface right on Linux.
You bring a good point, because one of the challenges that we had a few years ago with actually one very large Japanese automotive OEM is they were using a very specific solver called Convergent Science is the name of the company, but it's Converged CFD. Converged CFD is basically used for combustion simulation.
Okay.
And they have their own mesher, right? So a mesher is basically the application that prepares the simulation. You add, metadata or other types of data to a data set before you run the simulation. And so they have this application that they have to run on a cloud-based workstation before they run the simulation. And then, of course, after you run the simulation, you want to view the result. Now, for example, ANSYS has a product called LS-DYNA.
Okay.
If you upload about a 40 gigabyte file for a crash test, if you go to download it, the downloaded result is about 10x of the uploaded file.
Okay.
So you can imagine how long it takes to download 400 gigabytes.
It doesn't work.
It doesn't work.
Yeah.
So you need, for a lot of the post-simulation analysis, you need an engineering workstation on the cloud to kind of review the results.
So you say they have teams around the world, so they need to provide access to different parts of the world. I assume they also have a need to keep protected the intellectual property, so the file should live on the server side and also demand quite compute power. Probably is a combination of all of these things.
Right. And increasingly also their researchers, they want to work remote. So if you're going to enable that, you have to protect your IP, you have to protect your assets, you have to leave them in a safe environment to trust, right? And then have people access, from their OS.
We have a case from one automotive industry customer, and they basically, the process for onboarding a new employee through the HR. So instead of having to buy a powerful desktop for the new employee, let's say they hire a consultant abroad, they basically just give the employee a server address, a username and a password, and they can in 10 minutes get on board, basically.
Also, you have to worry about security, right? And you can actually lock down the environment that's on a cloud instance more effectively than you can a physical, desktop. So there's that as well.
Several benefits.
Yeah.